Number 10, the diagram below, not drawn to scale, shows a circle center O. RQ is a diameter, and PM and PN are tangents to the circle. Angle NPN is 54 and angle RQM is 20 degrees. They show that on the diagram. Calculate, giving reasons for your answer, the measure of angle MRQ, and that is going from M to R to Q. That's going to be this angle right here. Right, so we have to look out for some common things, and they tell us RQ is a diameter, and there's a rule. 2 points from the diameter, when they meet at the circumference, it makes a 90 degree. So we know that angle RMQ is 90 degrees because the angles in semicircle, the angle in a semicircle is equal to 90 degrees. That's a rule. Right, and then we could easily work this out because we know the two other angles in this triangle. So angle MRQ is 180 minus the sum of those, 90 plus 20, and we'll end up with 70 degrees. Sum of the angles in a triangle equal 180 degrees. We know that. Part 2, we want to find angle PMR. I'm going to do it up here. Angle PMR is going from from point P to point M and then towards point R. So we want to find this angle there. Right, and all we have to do is realize that this exterior angle is equal to the opposite interior angle. So angle PMR is equal to 20 degrees. Right, and then the third one, angle PMN. So from P to M and then down to N. This whole angle there. And they give us some clues up here. PM and PN are tangents. And the tangents from a certain common point, they're always equal in length. So this forms an isosceles triangle where this angle and this angle are the same. So let's work it out up. We could work it right here. Angle PMN is equal to, we could subtract the 54 to get the remaining amount of degrees in the triangle and then equally split it into 2. And we work this out, we should get, I believe it's 63 degrees. Right, and the reason is it's an isosceles triangle because tangents from a common point are equal. Tangents from common point are equal. Okay. This one, the diagram below, not drawn to scale, shows the position of 3 points A, B, and C on a horizontal plane. AB is 174, BC is 65, and AC is 226. Find the measure of angle ABC, which is the angle going from point A to B and then B to C. We want to find this angle. Right, we have 3 sides and no angles in this. So we cannot use sine rule because we don't have a pair. We're going to have to use cosine rule, which is They give it to you in the formula sheets, so you don't have to stress too much, but you do have to remember what these terms represent. The main thing is this side A pairs with this angle A, and then B and C are the other two sides. So what I like to do is pair my angle and side first. So whatever angle you're dealing with, that's angle A. The corresponding side would be side A, and then the other two are B and C. And we could just enter this in the formula. Right. We plug in these numbers where they're supposed to go. Okay, and if you want, you could simplify all of this. 51,076. We can add this and this because these are just numbers. 174 squared plus 65 squared is 34,501. We have to be extremely careful with this because all of this is one term. We have 2 times 174 times 65. Okay, so we end up with this line, and we need to get theta by itself. To do that, we need cos theta by itself. I prefer working with positive, so I'm going to move this to the left, and I'll move this 51,076 onto the right. So we would be adding the 22,620 cos theta, and we would be minusing the 51,076 when we bring that over. We can work this out. And we get minus 16,575. We could bring this number over. Opposite of multiplying by this would be dividing by this. And to find the angle, we're going to have to use the inverse. Cos inverse of this entire thing. Make sure you use brackets in the calculator. And I'm getting 137.1 degrees. It's an angle, so put the degree sign. Okay, so we know this angle is 137.1. And to find the area of a triangle, there is a shortcut formula if you don't know the base and the height, because this is not a triangle where it's easy to find the base and the height. We could use a half AB sine of angle C. And A and B are two sides, and angle C is the angle in between. So we just found the angle in between, and we have these two sides right here. We can just plug those in. A half times 174 times 65 sine 137.1. And we get 3,849.5 meters squared.